Hello and welcome to another video. We're going to be continuing on with the blind 75 in TypeScript, and we're going to be doing search in a rotated sorted array. So in this problem, there's a bunch of numbers sorted in ascending order with distinct values, and they can be rotated as shown in this example. So here, as you can see, it goes 0, 1, 2, and then it kind of loops around to 4, 5, 6, 7. So this is essentially 0, 1, 2, 4, 5, 6, 7, but it's rotated. Same here, and this is another number. But they could also be like this, so you could have very well numbers that aren't rotated at all. It's optional rotation. And then you're looking for a target in here, and then you want to output the target's index, or -1 if it doesn't exist. So in this case, for 0, this would be index 4, this would not exist, and this would not exist. And so the traditional way to do this problem is, I'll go over it briefly, but let's say we have some array, and so we just have like 4, 5, 6, 7, 0, 1, 2. The traditional way to do this problem is to find a rotation index, meaning you want to find the smallest number in the array, and you can do that. And then from there, you can divide your answer into two subarrays. Like, let's say you get the smallest number, you can divide it into this array and this array, and then you can just figure out like where your number has to be. Like, you know that this right array is 0 to 2 and this left array is 4 to 7, so you can figure out what range your number is in. We are going to look at a more, I guess, like a cooler solution that is not super common, because we are doing TypeScript and I don't want to show the standard solution that most people know if they've seen this problem. I want to show something a little bit more unique. So the thing to recognize for any type of array, there will only be one rotation index or there will be none, right, for any subarray. So any subarray I take, it will either be completely ascending or it will have a drop. So as you can see, like this 4, 5, 6, 7, completely ascending, 5, 6, 7, completely ascending. Here we have a drop. So our array will either look like straight up, where it's completely all ascending, or it will be ascending, then you'll have that rotation index, and then it will be ascending again, right? One of two cases. But either way, you can separate your array into a left side, an ascending side, and then the side after the drop. And that's what we're going to focus on in our solution. So we're going to have an ascending side. It will either look like this or like this, right? Strictly ascending or ascending, drop, ascending. And it doesn't really matter for us, because we are just going to be checking if our element is in the ascending side to start off. So essentially, we're just going to check, like, okay, is it in the ascending side of our array? And if it's not, then it has to be in this side. So even if it doesn't have this bottom side, it's just always going to be here, which is totally fine. So now the way we're going to do this problem is a little bit different. So we are going to have a target. And what we're going to do is we are going to binary search, but we're going to binary search. We're going to do a one-pass binary search. It's still the same time complexity. Technically, it's still going to be log n, but it is something like cooler that you can do. And so what's going to happen here is we're going to, like, let's say we have a pivot value. We are going to check, is our pivot value in, let's write down this left side, this ascending side, or is it in this right side? And some will only have the left side, right? Some will either have a left and a right, and some will have a left and, or just a left. Okay, and the way to do that is pretty straightforward for the pivot value. So we're going to do this for the pivot and the target. So for the pivot, we're going to say, is it in the ascending part? How do you know if it's in the ascending part? Where you can just compare it to the 0 value of your subarray wherever you're at. And if it's greater, then it has to be in this ascending part. And if it's less than it has to be in this other part. So that part's pretty straightforward, because every value here is going to be smaller than this, and there are no duplicates, so we don't have to worry about like any of that. Okay. And now what we have to do is we have to actually figure out like where it is. So let's go through this example. So in this example, what we need to do is we need to figure out where the pivot is at. And so in our case, let's just make a left and right. So a left is going to be over here, and a right is going to be over here. And we can probably make this a little bit bigger just to make it like easier. There we go. Okay. So our left is right here, our pivot's over here, and we're going to say, okay, is the pivot in the left side or the right side? Well, it's greater than the left, so clearly it has to be in the left side. Okay, so for this example, the pivot is on the left side, so we'll just say pivot equals left. What about our target? Our target is 0. So is our target on the left or the right? Well, what's our target? It's 0, right? Is 0 greater than 4? It's less. That means it has to be on the right side somewhere. So in our case, the target is on the right. So if we look at this picture, our pivot is over here and our target is over here. So obviously, if the pivot's on this side and the target's on this side, if they're on different sides, and you can either have this way or this way, then for the binary search, like let's say you had this case, you would just want to take all the numbers to the left of the pivot. And then if it was the other way, you would take all the numbers to the right of the pivot, right? You know what to discard. And we are going to have a check for the pivot being the target. That's going to be the first part. But in this case, our pivot's on the left, our target is on the right. That means we can discard this section and we can move our pivot. So let's do that. So we're going to move our pivot and we're going to discard all of this. Let's actually just delete all of this and let's make a new right value, or a new left value, sorry. So now our left is over here. And now our pivot, the one we're going to look into, is going to be this. Let's get rid of this. Well, let's leave that. Okay. So now for our, let's do this again. So for our pivot, this is the subarray. Is the pivot on the left or the right? Well, it's greater than this left value, so it has to be on the left side. It has to be on the increasing side. What about the target? The target is also on the left, right? Actually, yeah, the target's on the left. So what you can do for the target is you can just make it greater than or equal to this left value. Yeah, we're probably going to want to do that. Okay. So if the target's on the left, then you could also check if you wanted to. So like in this, we kind of ran into like an edge-ish case, but it doesn't really matter. So so our target is on the left. Like I said, let's just make sure that like it's less than, or that for the target, we're going to check greater than or equal to, because our target could be that leftmost value. So it's on the left. Okay. So now they're on the same side. So our pivot and our target are both on the left. Now we're going to do the same thing where we have to compare the pivot to the target. Now it's a little bit different here. So in the case where they are both in the same like side, it's pretty straightforward because it's just a normal binary search, right? Like this is completely sorted and this is completely sorted. So if they're in the right, if they're in the same side, you just check like, okay, is our target greater than or less than the pivot? In this case, it's less than. So if it's less than, we want to get rid of this side. And if it was greater than, then we'd want to get rid of this side. So that part's pretty straightforward. So if they're both on the left, here our target is less than the pivot. So we're going to want to get rid of all of this. And then our right will be over here. And then finally, when we get a new pivot here, we will have the right value. So let me just sum this up. So one pass binary search. Each time check if the pivot and the target are on the right or left side of the array by comparing to leftmost val. If both on same side, simple binary search check. If diff sides, eliminate the side that the target is not on. And that's pretty much it. And then once out of values, return -1 or return target if found. So that's pretty much it. And then for this, it would be the same thing. We would just check every time. But yeah, so we did notice that we do need to have this one little check. We could also check if we wanted to, if the target was equal to the leftmost value, to get rid of this, like, that would work as well. So we could just say, like, if the pivot equals, if the target equals the pivot value, let's return the pivot index, and if the target is the left value, let's return that. So we'll add that into our code, I guess, just to get rid of that condition. Or you could just say if your target is greater than or equal to the left, but we'll just compare them. Okay, so now we have everything we need to be coding, so let's do that. So let's take a look at our TypeScript. So it's going to take a numbers array and a target, and it's going to return a number. So that part's pretty straightforward. And let's start coding. So we need a left and a right. So we need left equals 0, and then a right. And then a right is going to be nums.length -1. And we're going to have a normal binary search, right? So while left is less than or equals to right, we're going to make a pivot. We need to do math.floor because we want an integer. So we're going to do, this is going to be a left plus right. I don't think there's overflow in JavaScript, but if you wanted to do like the more conventional way, you would do right minus left plus left. But we'll do it this way because I don't think there's overflow here. Let's see. Cannot find name right. Okay, there we go. So we have our pivot. And now what we need to do is we need to check which side the pivot's on and the target. So we're going to say let pivot side. But we do also need to, we want to check if the pivot is actually equal to the target. So let's do that first. So we're going to say if nums pivot equals target, let's just return pivot. And then we'll also check the left value. So if nums left equals target, let's return left. Okay, so now that we have those checks, now what we need to do is we need to check which side the pivot and the target are on. So let's do that. So we're going to say let pivot side equals, and then it's going to be true, like true is going to symbolize that the pivot's on the left. So we're going to say nums pivot is greater than nums left. And the nice thing is if nums pivot equaled nums left, we already checked for the target, so then that can't happen, right? Like, then we would have already returned. Okay, so let's do that. Now let's actually get the target side. So let target side equals nums target is greater than nums left. And same thing, it can't be equal because we would have returned already. Okay, now we have two cases. The pivot and the target are on the same side or they're on different sides. So let's handle the same side. So if pivot side equals target side, then we have a simple binary search where we just check which side it's on. So we could just say nums pivot is greater than target. We could check for that. And if that's true, so if nums pivot is greater than target, then what are we doing, right? Like what are we actually updating? We want to be going left. So to go left, you do right equals pivot -1. Don't need that. Otherwise, left equals pivot +1. Okay. Now we can check the other sides. So now this is them being on different sides. So if they're on different sides, we just need to figure out what side the target is on, right? Pretty much, or what side the pivot is on, and we just make the opposite. So we could just check like for pivot side, and whatever side, so let's say this is true, that means the pivot's on the left. So if the pivot's on the left, then we want to go to the right. So how do we go to the right? Well, we want to do left equals pivot +1. Otherwise, the pivot's on the right, so then we want to go to the left because the pivot and the target are on opposite sides. Okay. Now we can actually test our function. Oh, we forgot a couple things, actually. We want to have a return value when we don't have a solution. But now we can actually test our function, so we can just console log a couple things. We can actually even pull up our picture. So what are our numbers here? 4, 5, 6, 7, 0, 1, 2. So we can look up search of array 4, 5, 6, 7, 4, 5, 6, 7, 0, 1, 2, and we are looking for 0. And you could see it's index 4, so that works. Let's have a couple more tests. Good to make your own tests. So what about if we're looking for something that doesn't exist, like 3, well, that works. 9, that works. 7, that works. And let's make a couple more tests. So let's also test in a completely sorted array. So if we just have like 1, 2, 3, 4, 5, 6, 7, let's test a couple numbers in this one. So let's test for 1, that works. 2, number that's out of bounds. Okay, let's test in an array of size 1. Let's test for 4, that works. Test for 1, also works. So we can see kind of like everything is working. So now we are just going to take this up to LeetCode and let's just try to copy it in. So let's just copy this part. And let's copy it in. Not tabbed correctly, but that's okay. Okay, and we can submit it. So we do have a problem, so let's look for this, and let's do some debugging. So for 1, 3, we're looking for 3, we're outputting -1. Okay, and let's go through that logic. So let's test that in our code. For 1, 3, we are looking for 3, and we are outputting -1. Well, the nice thing about Quokka is you can also, obviously you can't use this in a real interview, but in Quokka you can. but you can just add console logs. I mean, I guess in a real interview you could also add console logs. But essentially, let's just print some stuff. So let's just print left and right for 1. Okay. So as we can see, our loop is only happening once here. So what should happen? Let's also print maybe the pivot. Not a bad thing to print. So let's do that. Now let's console log the pivot. Okay, the pivot is 0. And so what about the pivot side? So let's think about that. Like, where should our, we can console log both of those as well, I guess. So pivot side and target side. There we go. Okay, so it looks like it says the pivot and the target are both on the right side here. And does that make sense? I don't think so, right? So they're saying but they're both false. Well, technically, this is a strictly increasing array. So let's think about that. So num's pivot is greater than num's left. Well, num's pivot, so actually, as you can see, we do have an error here. So num's pivot is greater than, but num's pivot actually equals num's left. But num's pivot is equal to num's left, but the target does not equal. So we need this here. And now let's see if we have a correct, and now we have a correct solution. So that's what we were missing here. And I believe you can actually do this if you wanted to, and let's test this out though. So we can actually get rid of this check if we wanted to now. I think this should work for other stuff now, but let's give that a try. Because essentially we're saying if they are equal to num's left, then they're on the left side, and that's what we forgot to check for in our problem. So let's actually copy that in. I mean, obviously console logs, let's get rid of those for efficiency. Obviously we don't want an export. But yeah, that's why Cocoa is really nice for debugging. Obviously in an interview you don't get to have it, but you still practice like console logging and stuff. Let's take a look if we have any issues. Undefined. I think we have like too many things here. Or what's going on? Oh, we have 2 searches. That's what it is. So let's just get rid of this. Okay, now let's see. Okay, so now we broke something else, which is kind of interesting. So let's go back. So I thought it would be fine, but apparently we broke something else. So here, if we look for 0, that broke. So I think what we should do in that case is we should add that target back in there. So we can just say, yeah, I think we do want to add that back in. Let's just double check. So if num's pivot equals num's left, I think that's the one that's like getting screwed up, because that's what we had in there that worked originally. Return left. And now we need this just strictly greater. There we go. Okay. So good to test and good to see that, like, careful getting rid of stuff. I definitely didn't have to get rid of that. I just thought I wouldn't need it, but it turns out you do. But in an interview, probably best not to get rid of stuff unless you think about it. Get rid of these console logs. Now we should be good, I think. But let's just double check. Let's copy in this code now for the last time, I think. And let's see. Oh, did I copy that in correctly? Jesus, we're breaking everything. Okay, let's test for 3. Okay, so it's saying it found 3, which is curious. Okay. Oh, right, because we have a mistake. Yeah, so this should be num's pivot. Yeah, this should be num's target. Or this should not be num's target at all. This should just be target. There we go. Okay, and let's check for that other case as well. Okay, there we go. Okay, cool. Now, for sure, surely we don't have an issue. But yeah, that's the other thing about doing something. Okay, hopefully we're good now. That's the other thing about this problem. Okay, Jesus Christ. Okay, let's try this one. 351. Apparently we're running into issues all over the place. Wrong one. Okay, so let's console log there. And what are we looking for? I think we are looking for 1. Let's go through this one. Did get rid of the console logs. Okay, so it's not finding it, so let's console log again. So I didn't screw up anything else, but okay, let's leave this. Let's also console log the pivot. And just follow the logic here, and let's console log the sides. Pivot side and the target side. Okay, so let's go through this one. So our pivot here should be this value here. So the pivot side should be the left, and the target side should be the right. Let's double check that. Num's target. Oh, right. Jeez, I made so many copy paste in a rush that I kept making mistakes everywhere. This is ridiculous. Okay. Okay, for this 17th time, let's definitely. Okay. Let's pray it works. Yeah, I'm just like copy pasting too much, and it's I think it's screwed up. This is a problem, but what the 5133? Didn't we return 2 here, or did I not see that? 5133. Yeah, it should be correct. Or it's 513. Let's see here. Okay, it's returning -1. What is going on? Target 3, output -1. Okay. So let's follow this one. Okay. So what are we doing here, and where's our pivot and our target? So our pivot's here. That means our pivot's on the right side. Our target's also on the right side for this first case. So if our pivot and our target are on the right side, then this left value should... Yeah, our pivot is over here, and our target is over here as well. Oh, I see. What? No, sorry. Our pivot is over here, and our target's over here, but our target is bigger than our pivot. So let's just double check that. So if num's pivot, they are on different sides. Here we go. So the pivot side is left, pivot +1. Or actually, sorry, they're on the right side. What am I doing? Okay, if num's pivot is greater than target, then we have to go left. Yeah, so here our num's pivot is less than target. Oh, I think, yeah. I think we're going the wrong way. So if also, yeah, if the pivot is greater than the target, the pivot is less than the target here. Yeah, and our new, yeah, so we should be going, it's going here for some reason. Like we're deleting this, but we actually want to be deleting the other side is our issue here. So let's just go through this one more time. So if num's pivot is greater than the target, then like it would be like target, and then the pivot would be here. Okay. And then we'd want to go left, which is fine. And then if num's pivot is less than the target, yeah, so in our case, num's pivot is, num's pivot is less than the target, so we'll do this case here, left equals pivot +1, but yet it's saying it's 0, 0. So let's console log here, just to make sure we actually got to this. Oh, okay, I see our issue. So definitely interesting debugging. So I don't know if you guys spotted that, but our problem here is we want to compare if they're equal, not if they're both true. So they're both false, so we need to actually make them equal. Okay. For the 5 billionth time now, let's compare that. Jesus. Okay. Okay, nice. So like as far as the test cases, well, actually we can get rid of the console logs and make it a little bit faster. It is still going to be log n, so like the time and stuff doesn't really matter. Like it's still going to be log n, it's just a LeetCode thing. But let's just see here. So you could do the rotated index if you wanted to, totally fine. Yeah, the console logs do slow it down, but that is also one thing that I will say that you have to be clever about. Like I was doing this problem because it's something new, but doing something like tricky and new can definitely has some consequences where you will run into more bugs just because it's a little bit tricky and you might like run into corner cases. So I would say, like, obviously during an interview, I'd probably have a much more generic solution, not as tricky. I just try to focus on getting it correct. I wouldn't try to like do something fancy because there's a lot of things that can go wrong there, as you can see. But yeah, so for the time complexity here, it's actually going to be log n, and for the space, it's going to be O1. It's going to be O1. Yes, it is. Yeah, because we are just having a left and a right. But yeah, hopefully you enjoyed this debugging session. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.